recording now, and then you can start your presentation. Thank you.
Thank you, Kim,
Are
for
you
the
here?
kind introduction. Can you hear me?
Yes, we can. Thank you.
Yes. Can you see my slide as well?
I can see your slide and you are ready to go.
Right. Thank you very much. Thank you for the kind introduction. Hello, everybody. I'm very happy to share ASC research help for nutrient in a circular economy, which is called ASC Nice Hub in short. So we live in a linear economy, which we just take the make and use and dispose, which is not sustainable. So we need a circular economy. It is an economic system that tackles the climate change, biodiversity loss, and waste and pollution. So Australia could generate $2 billion in direct economic benefit from this circular economy and save the 165 million tons of the carbon dioxide by 2040. So we are very much interested in this circular economy system. In particular, I like to introduce the nutrient balance in Australia. So you can see the what we are handling for this nitrogen, phosphorus, potassium. So you can see how we are imported every year, and then how we utilize to grow food. So, and then we export around 20%, and we consume this food internally, and almost 50% during the processing, and then we just have food waste losses. And we have almost 20% and directly converted to wastewater. That's the reason why the ASC Nice Hub tried to convert this NPK for fertilizer. So we have 3 different locations. So Sydney, and Brisbane, and Melbourne. So each location has a different scale of the some urine diversion system at a building level, as well as some of the parkland and then mobile toilet system. So we try to look at how we can optimize the different application for urine diversion system to collect the nutrient for fertilizer applications. Also, we try to collect our nutrient from wastewater and industrial wastewater and animal wastewater. Also, anaerobic digestion, we can produce a lot of nutrient, and we want to utilize our nice technology to convert this nutrient to fertilizer to produce the edible crops and greener environment, also non-edible crops, green building, and tough classes. So that's also our objective in a broad range of the application. Specifically, ASC Nice Hub will be a key partnership to transform the wastewater industry to build the confidence for market in using wastewater and urine as a source of the fertilizer for agriculture, horticulture, and parkland. So we have 4 major themes. So urine collection, together with the toilet manufacturers, regulators, and operators. And second theme is the processing, regulator, and technology providers. And fertilizer optimization, health and fertilizer industry. And last, the fertilizer end user. So we want to apply in parklands and agriculture, also horticulture application. And we want to have more communication as well as the economic. In more detail, so we have 10 projects. So this is the relate to urine collection. So downstream impact and nitrogen peak shaving in sewage wastewater treatment plants, and toilet design and nitrification options. And second option is that we have developed the 2 technology. One is the UGOL and Aubois system, so how we can make upscaling and field demonstration. Also modify technology configuration to produce the tailored fertilizer, assessment of the chemical, biological safety, and predicting behavior of urine-based fertilizer in soil-based, and assessment of our urine fertilizer for suitable end user with plan, evaluation of the demonstration of our urine fertilizer efficacy in field trial. Also, we want to look at the more specific economics and engagement, learning and communications. So that we need a collaboration. So we have 7 universities in Australia, and we have also 22 industry partners, and they are mostly water utilities, also some of the private industry technology company, and some of the government application of our fertilizer, the botanic garden, as well as the parklands. So we have many different multidisciplinary industry partners to work together to make this nice happen. Also, we have 3 international organizations, E1, UNIST, as well as the Rich Earth Institute. And first technology in Sydney, we have 15-story the urine diversion building in our university, and then we have collected urine every day more than 1,000 liters, and then we utilize this membrane bioreactor system and distillation and produce the ovals, and we have tested some of the vertical farming system. And this is our lab scale and pilot scale. And this is the oval fertilizer, which means that you are valuable and urine is valuable. So we try to make some application for this fertilizer produced from the building level of the fertilizer system. And this is our example of the test to grow lettuce and pak choy. So we have tested some of the commercial fertilizer optimum and standard fertilizer together with the oval fertilizer, which showed very much similar performance. Also, we have tested with the Royal Botanic Garden, parsley, also lipsalis, and we have tested some of the hydro garden system to grow basil and coriander, and we found out very good performance. This is the oval fertilizer and commercial fertilizer without any fertilizer, only deionized water. And then our fertilizer showed a very good performance compared to the other commercial fertilizer. Also, we have second Brisbane node, microbial electro concentration technology. So this is hydrolyzed urine and pass through this system, and we have cation membrane. Only cation ion will pass through ammonia, potassium, and this feed water goes to the next step, and we try to concentrate hydrogen phosphate or some of bicarbonate. So this is the concentrated fertilizer, and we can make waste, so we don't need any power, chemical, not much process control. So this has been developed for application of the parkland in the city. So they have tested this kind of containerized system. You can see some of the lab scale, 90% volume reduction, 50% nitrogen recovery, kill pathogen because of the ammonia, more than 25 grams per liter, and power consumption mainly for pump, around 7 kilowatt-hour per kilogram nitrogen. And then most of the microplankton were removed from this electrochemical process. Also, in Melbourne, we are trying to collaborate with the Southeast Water, and they have developed some mobile toilet, and then we try to put our urine diversion system, as well as our technology and combined with the vertical farming. So we have time for this mobile toilet to collect our urine and then try to process on the spot. And we want to utilize to grow some of the plant. So that's the three nodes. We want to develop different scale, different technology, as well as different mobility situation. So this is the so far we have done for the last 4 years. And then this project will go another 4 years, because last 4 years was only for our small project, but now it's from this year, we will collaborate together through this ASC Nice Hub for next 4 to 5 years. So this is our lab scale, small scale fertilizer, different characteristics. So this is the commercial fertilizer and Aurin from EWAG group. And this is our first fertilizer, second fertilizer, which means second batch. It was produced from 2018 to 2020. This is produced from 2021 to 2020 from the university building. And this is the UGOLD electro technology process. And you can see most of the fertilizer ratio NPK, 10, 3.37, 10, 1.4, 10, 1.4, 3.5, 10.26, 3.3. Very much a similar ratio we have identified for this urine fertilizer system. In the future, we will look at more detailed registration, certification, and safety data set and labeling for our oval and UGOLD fertilizer, also demonstrate for long term with the prioritized stakeholders, distillation impact for nitrogen loss, and national mobile toilet design optimized operation has to be investigated for next couple of years. Also support 3 nodes for their scale-up demonstration. Also, yeah, we need more public education acceptance. And we will have an official launch of the ASC Nice Hub and Nice Summit on 17 November. So if you're interested, yeah, we will open for online. Also, if you're interested, you can join in person. So it will be held at the University of Technology, Sydney. So you are very much welcome. And I'd like to thank you for students and our collaborators and all the industry partners, also funding from Australian Research Council. Thank you for your attention.
And thank you, Dr. Shon, for a very wonderful visual ability for us to see what's actually going on in Australia. We all can't get on planes, and I think this was one of the best ways for us to see what's actually going on there. We're really excited about all these developments. Please, I want to remind everybody to put your questions in the chat. We will have questions and answers at the very end and after everyone's presented. So thank you again, Dr. Shon. And without further ado, I'm going to bring on the next presenter. This is Nadège de Chambrier from VunaNexus, examples of large-scale applications of urine nitrification. So Nadège de Chambrier is an environmental engineer from Etz in Switzerland, specializing in wastewater treatment and recycling. After a master's thesis on decentralized wastewater treatment plants in India, she started working for Vuna on developing and optimizing further the urine treatment technologies. Now, the co-founder of VunaNexus, she is responsible for project planning as well as development of the technology. So Nadège, the floor is yours. Thank you.
Thank you. Thank you for the presentation. Can you hear me well and see everything?
Yes, we can see you and hear you.
Great, perfect. So hello, everyone. Today I'm going to present VunaNexus. Our company is based in Zurich on the campus of EAVAG. We are kind of a spin-off of EAVAG, and we base our technology on what has been developed over the last 15 years on urine nitrification here in Zurich. And during this presentation, I'm going to give some examples of large-scale applications. But first, I'm going to explain shortly what we do. So basically, For nitrification, what we do with our technology is that with bacteria, we can transform any type of urine into a concentrated fertilizer, and we remove all the unwanted pollutants. Our process is fully automated and patented, and what we do is that we install it inside of a building. So basically, we treat urine that has been separated with urine diverting toilets, be it toilets, flush toilets, dry toilets, or as well as urinals, for example. The urine is diverted into a storage tank in the building, and then with nitrification, what we do is that we feed the urine to bacteria, and we give this bacteria some air so that they can do their nitrification. The nitrification is basically transforming ammonium that is in the urine, in the stored urine, into nitrate. And this step allows to remove all bad smells from urine. And this is what we call a stabilized urine afterwards. So it doesn't smell anything, and it doesn't pollute the air anymore. The next step in the process is that we remove pharmaceuticals with the aid of an activated carbon filter. This allows for the product of our process to be used on any type of plants, including crops or edible plants in general. The last step, and a very important one, is that we concentrate the product into a fertilizer, and this concentration is done with vacuum distiller and at high temperature, and this allows not only to concentrate and not to transport huge amounts of water, because urine is mainly water, but also to remove all pathogens found that could be found in the urine. So the advantage of this system is that we can recover all nutrients, including the micronutrients like iron, which are very needed by the plants as well. And that it doesn't need any chemicals. We only need basically electricity, some air through an air pump, and that's it, and the bacteria, which we have already grown. So the product of this system is basically at the end of the system. So at the end of this distillation, the last step, we have a ready product, which is called Aurine. And it's this bottle that you see on the right. It's a fertilizer that is permitted now, allowed to be used on all types of plants in Switzerland, in Liechtenstein and Austria. Austria since this year, so we're really happy about it because it's a first step for going into Europe, into the European market. We are now looking into permits in France and Germany as well, because we have future projects there as well, which I will talk about right away. Currently, we sell almost more of this product than we can produce. So we collect a lot of urine, but we also have a vast community of people buying it. So buying it, as you can see here, as a bottle, which is a ½ liter, but also from business customers or public customers like the city of Zurich or Lausanne, who use it for their parks or gardens. One goal that we have as well will be to at some point receive an organic label for this fertilizer, but this is another step, and it will take some time. The first case study I want to show is about the use of Aurine on a soccer or football field in Zurich. So it's only 10 kilometers from the production site, and the city of Zurich was very interested to do some tests. And the advantage with those tests is that we are implicated only by delivering the fertilizer, but it's completely independent. The results are independent from us. And actually, the client is very happy about the results. So what they did was to compare Aurine in different concentrations on the field, as well as comparison with a synthetic fertilizer. And they did high precision spreading, which allows to really make sure that the dosing is right, and allows as well to really see the differences on the field. Actually, there were not that many differences seen between our fertilizer and the standard fertilizer on the market. So it's a very good sign showing that it's very advantageous to use a local fertilizer produced in Switzerland instead of some fertilizer which might contain other products which we don't want in our earth and which are imported from far away. Another important part of this is that we can show that CO2 can be saved by the use of using our fertilizer on fields. I unfortunately don't have that much time to go into the details of this. The next, now I'm going to show you 3 different projects. The first one is EAVAC, which now you probably heard quite a bit about if you have been to this summit. So EAVAC is based in Zurich. This is where our technology comes from. And so basically there were urine diversion toilets, which were installed already 15 years ago in one building. So this main building, the one you see in green. And we have been treating about 100 liters of urine per day in this building for the last 10 years. And last year we updated this system because 2 new buildings were connected. One of them also with the Rödiger toilets and the other one with the Lauf and Save toilets, so all flush toilets, but also all different types of urinals. And so we needed to have a system, the client needed to have a system that could treat more and up to 400 liters per day. And so we connected those 3 buildings with what we call the urinoduct, which is basically a pipe for urine. So this pipe links the 2 buildings on the side, the ones in blue, to the building in green, where the treatment site is. The advantage of this site is that it's allowing us to all the time optimize our system, but also it's really an example for all types of toilets, of urinals, and also we can see that we can even recycle the water as toilet flush and that it works perfectly. This is what we call the kind of centralized plant in our case. I'm going to explain that right now. So EAVAC is a centralized plant because we treat urine. I mean, originally we treated urine from one building, and we do that all on site. Here, I'm going to present a project which is semi-centralized. We will treat urine on a neighborhood, which is in Hanover in Germany. And this is part of a Horizon project. So it's a big project, which is funded by the European Commission. And this is a project with a lot of different partners. So it's a very important project in Europe. What we are doing here is not only treating urine from buildings in this eco-village, but also receiving urine from portable urine diversion toilets, which are rented by Goldheimer, our partner on this project. So it's going to be interesting to do the mixing of both and to see the logistics of this. The construction will start next year and the project starts at the end of the year. So we're very excited about this. The next project I'm going to mention is zirkulierBAR. It's in Germany as well. And this project, we call it fully decentralized in the sense that we have a treatment where there is no urine produced on site, and urine is actually all of the urine will be brought to us by Finizio, our partner on this project. And this is a very important project in Germany, as well as in Europe in general, because it will show and give some blueprints to communities on how to do urine separation the best and how to treat as well all elements from dry toilets from portable dry toilets. I will not go in more details because Carsten will talk about this project just in a few moments. And now just to discuss a little bit about the business model. It's often a question, so how do you do it? And So just to explain the idea in the case of buildings, so what we do is that the client will invest, so the building owner will invest in the infrastructure, so the toilets, the piping, etc. But they will also invest in a treatment plant that we sell. And our concept is that after that, the client doesn't have to do anything else. So we plan, we build, and we operate and maintain the system, so the treatment process. We take care of everything, as well as the fertilizer logistics, because often clients tell us we don't want to be a fertilizer reseller. We are happy to do something for the environment, but we don't want to go further than that. And so that's the model that we found makes the clients happy, and that is for us making the most sense. It allows for us to, with the sales of the fertilizer, to pay a rent to the building owner. And this way the building owner can plan their return on investment, which we calculated to about 10 to 15 years, depending on the size of the systems. This way we have control on the fertilizer quality, mainly. This is what's the most important, and on the sales, and we can manage the sales as locally as possible. So this is the label that our fertilizer has in Switzerland. I mean, it's translated to English, but if you have any questions, let us know. You can contact us, and if you need any more details about nitrification or what we do at EAVAC, I'll be happy to give you some more information.
Nadège, thank you so much. That was a wonderful update, and really excited to hear about all these new developments. Make sure if you have questions that you put your questions in the chat. And we're going to keep moving right along this morning. We're going to next hear from Valentin Aubois-Liogier, who will be presenting Urocyclus, an overview of an ongoing urine recycling project. Valentin is a PhD student in design and urban planning at the University of Tours. His research aim is to study the experience of ecological sanitation systems for users and stakeholders, and especially urine recycling systems. So if you are there, Valentin?
Yes.
Okay.
Can you hear me well? Yeah.
I can hear you well now.
Okay.
And if you would like to share your screen, you may go ahead.
Right. Okay. Do you see my screen?
I see your screen and I almost, yes.
Okay.
I see your screen and we can hear you. So
all right.
Take it away.
So hi, first of all, I would like to say that I am very glad to present my project here today. And thank you for listening to this presentation. So my name is Valentin Aubois-Liogier. I'm a French designer and I'm currently doing a PhD in design and urban planning. So today I will present you the ongoing research project Urocyclus. In 2020, as a master student of the École Normale Supérieure Paris-Saclay, part of Paris-Saclay University, I moved in the new buildings designed by Renzo Piano building workshop, in the territory of Saclay, in the south region of Paris. Building plans were printed on flyers and distributed to help us navigate in this new environment. And I was very surprised to discover that toilets were not indicated on the plans distributed, and less surprisingly, but equally disappointing, that the gendered restrooms have only flush toilets. So I wrote a text imagining my impromptu meeting in 2018 in a Parisian cafe with an architect of Renzo Piano building workshops, who was working on the new buildings of this French institution for higher education. I highlighted the missed opportunities of building something new without addressing sanitation issues and experimenting sanitation alternatives. The same year, in 2021, I wrote a collection of text called 2022-2057, The idea was to imagine what could possibly happen at different dates in the ENS Paris-Saclay and in the territory of Saclay if a urine recycling system was implemented. Recorded readings of this text in French were also podcast later at the collective exhibition. At the end, I designed several scenarios and a set of objects for the recycle of urine at the ENS Paris-Saclay. The objects were a cabin and a urinal, which varied depending on the context, the scenario. This first part of my research was presented at the collective exhibition Issue de Secours at the ENS Paris-Saclay in June 2021. And the same year, I was laureate for PhD funds, and I started my PhD in September 2021, originally about social acceptability of alternative sanitation systems. So I am doing my PhD in design and urban planning at the CNRS CITER laboratory at the University of Tours, a city at 1 hour by train from Paris. Supervised by Denis Martouzet, an urban planner, and Suzel Balez, an architect. The title of my research is Relationship of Users with Ecological Sanitation, an approach through a urine recycling project. The urine recycling project is the Urocyclus project that I'm currently developing with the ENS Paris-Saclay for an implementation in 2023, so next year. This project is part of my PhD, and my PhD research used the research through design method, which means that I am studying the means and the effects of one urine recycling system that I am designing by designing it and carrying fieldworks with users. So here is the urine collection system as it is designed now. It should be implemented in 2 gendered bathrooms. Urine is collected with a dry genderless urinal attached to a wooden box hiding the plumbing system and the urine collection tank. The collection tank is emptied into a storage tank in the basement to store the urine 6 months. The stored urine is then used to fertilize vegetable garden on the rooftop of the ENS Paris-Saclay. So one photograph of a test model. To fertilize, as I said, the vegetable garden on the rooftop of the ENS Paris-Saclay, and possibly in the territory of Saclay in public garden and in crop fields. So, as I briefly said earlier, I am carrying fieldworks with users of the ENS Paris-Saclay and stakeholders to study their relationship with the urine recycling system through different methods, such as survey, focus group, interview, and observation. So social methods, mainly. Now I will present you some results from an online survey sent before implementation. The idea was to study the current practices in restrooms, and evaluate the acceptability of the implementation of the urine collection system developed for the Urocyclus project. So there were 145 respondents from June 2022 to July 2022. Every respondent were using bathroom facilities for various practice. Overall, there is a high acceptability for the use of the urine collection system for different reasons, mainly to save water, to save the environment, or for the recycle of urine as fertilizer. But also thanks to simple curiosity from the users. The main reasons of reject were the lack of comfort, the strong smell, or the lack of hygiene. it often was the fear of something that was leading to the reject. So based on the fear of these three last elements and the fact that nearly half of the respondents were motivated by curiosity, among other things, we can say that the first attempt to use the urine collection system, so the urinal, seems crucial for the sustainability of the entire recycling system. Hence, we should look closely on how urine is collected. So due to fund issues, the system should be prototyped and implemented first at the University of Tours for 1 or 2 weeks at the beginning of 2023, then implemented for several months at the ENS Paris-Saclay during 2023. Potential users between the two institutions are quite similar, even if the territory is different. So to conclude, the Urocyclus project aimed to study the factors of acceptance and reject of the collection device and recycling system, observe and analyze the socio-political issues arising from this kind of system, experiment the research through design method, and it could also help to frame other experimentation in the future. So thank you. I'm open to your questions.
Thank you very much, Valentin. Yes, people will have some questions and put them in the chat. It's great to be hearing about all these different projects happening. We're going to move on with to hear from Julien Saludas. Julien will be presenting about Lactopi Start, the first European-wide registered microbial biostimulant using urine as a growth medium. Julien Saludas is the R&D head of Toopi Organics. He manages a team of 7 microbiologists and agronomists, as well as R&D projects coordination. He is an agronomist with 15 years of experience in agribusiness companies in France. So we're really excited to hear from you. Are you ready to go, Julien?
I'm here. Yeah. Thank you.
Okay, and you can go ahead and share your screen.
Sure. Okay. Do you see my screen?
We can see your screen and we can hear you. Wonderful. Looking forward to it.
Wonderful. Thank you. Thank you for all. I'm very happy to be here. I had the chance last year to introduce Toopi Organics for the first time. So now I'm very happy to give you an update of our progress. So as you say, Toopi Organics is a French so-called startup located near Bordeaux. So quite beautiful city in France. We are almost 3 years old and also 19 employees. The technology is based on fermentation, in fact, which is quite different than the other technologies already presented. We start with urine collection in waterless urinals, and so we basically doing a frugal fermentation into microbial biosolutions after and also frugal upstream urea stabilization and filtration. And so our mission is to engage a truly closed loop regenerative agriculture thanks to urine. In terms of milestones, so we already collected millions of liters of urine in France, and we should also start in Belgium. We've got an industrial demonstrator of 250,000 liters per year in Bordeaux. We had the chance also to acknowledged by the French authorities and agencies and won more than 15 awards to develop a technology. And also our technology is patented through 4 different patents on in PCT procedure. And so we also the chance to get market approval in 6 countries in Europe for our first product that I will deepen a bit afterwards. And obviously we have also other kind of products in development. So maybe first of all, I just wanted to show you, I will say, why we started with this process to address what we call the regenerative agriculture. Here are the four main principles to build this regenerative agriculture, which are based mainly on the increased soil fertility by avoiding chemical inputs, by generalization of long crop rotations and also cover cropping, as well as protect soil life and erosion by minimizing soil disturbance by, for example, doing soil no-till practices, and also integrating livestock and nutrient circularity. And you may know at the right part of the slides what has already been presented in the presentation of Chelsea about urine-derived communities in terms of impacts to greenhouse gas emissions and energy consumptions, with a huge impacts in terms of urine directions towards this externalities. And in fact, microbes are the main pillar of regenerative practices. You may know that we have lots of microbes in the environment, specifically in soils and plants, what we call the phytobiome or the microbiome. And all these microbes have lots of uses and lots of roles in terms of production of plant hormones, to control pathogens, to help to do solubilization of nutrients like phosphorus, or to fixate biological nitrogen, or to help to the soil structure formation and water retention. So you have lots of microbes, and so I would say that the product based on microbes are called biofertilizers, and so there are lots of roles in agriculture to engage this regenerative agriculture, like nutrient fixations, nutrient solubility, to improve water uptake, and so on. So these microbes, I will say, are very interesting and absolutely and should be developed to engage ourselves in these regenerative practices. And so in fact, we think that urine is the missing link to engage this closed loop regenerative agriculture, because urine, of course, you all know that it contains all the required nutrients, and nitrogen, phosphorus, and potassium, and all the micronutrients. But of course, that's quite complicated to be, I would say, relevant to replace the mineral fertilizers, because of the technology and the fact that it's quite capex and opex intensive. And in the other ends, you have so the microbes, the microorganisms, and these microbes needs nutrients and growth factors to be produced and formulated as biofertilizers. And in fact, what we are doing in Toopi, we link both, in fact, and we use this urine as a perfect substrate to grow these microorganisms and to produce these biofertilizers. So in fact, this is the first of its kind urine-based biofertilizers or biostimulants. So that received the registration approval in France, Belgium, Italy, Spain, Portugal, and Greece in 2022. So this is a liquid form, because we keep everything at the end of the fermentations. So urine is used as a growing medium and also as a carrier of application. It is used as a spraying product, okay, directly in the field. At a dose rate of from 5 to 50 liters per hectare per year. That could be also split up to 6 times during the cycle. We can use also this product as a biopriming of seed treatment, which could also be interesting for some rows specific impacts. And we received the approval for lots of crops, like field crops, vegetable crops, industrial crops, and so on. So we have plenty of possibilities. It's in terms of mode of actions, that's also explained at the right part of the slide. It helps promote the plant growth and stabilize soil's phosphorus, which is called PSB effect, with a specific strain of bacteria, which is the Lactobacillus paracasei, that has been, I would say, used in the specific product, and that use urine as a growing medium, and help to have this effect. It helps to secure crop startup and optimizes the fertilizer use efficiency. And of course, because of the business model, it's a very competitive cost efficiency, I would say, biofertilizers in the markets. And of course, for environments, you have lots of positive externalities, like the drinking water saved by the recovering urine at the source is in the fact that it's a very low carbon footprint in terms of carbon emission. So you have the figure out here. So it's the chance to put in place fermentation, because fermentation is it's really frugal and low tech, so it's quite easy to I would say, and not very carbon intensive to produce this kind of product. Okay, I know that it's not, I would say, an agronomic courses, but I just wanted to show you some results which are quite interesting. So, example of our results on ornamentals, flowers, which is very easy to have view easily on the plant pots. So, which has been done in France on the type of flower. And you can see the right part when you use our product at a rate of 20 liters per hectare, and by decreasing the uses of the mineral fertilizers by 25%, that we have an increase of the root development, which is the main claims of the product. And it helps the plant to have access to the nutrients in I would say, regenerative practices. Other example in corn on the left, it's an irrigated corn, grain corn. In microplot trials in France, in southwest of France. Here you have differences between the controls of no uses of so-called starter, which is APP, a liquid phosphorus and nitrogen fertilizer, and then by using a product at a rate of 25 liters per hectare, with a significant increase of the yield, and obviously by increasing the margin for the farmer. And at the right you have also an example of corn, again, for the corn in Belgium, in this case, which is very different in terms of results, because we compare the decrease of by half of the APP, the same citizen fertilizer at the left part, sorry, here in orange. Here you have the full fertilization program for the corn. And here you have the fertilization program minus so divided by half with the use of the product at 25 liters per hectare. So we show that we could I would say substitute I would say roughly 80 liters per hectare of the liquid form for these fertilizers by keeping the same yield. And finally, for another example in potatoes, where again in microplot trials in France and Belgium, we also show that this kind of product can secure the yield and even increase the yield by securing the implantation and help the plant to access to the nutrients we have in the soils. In terms of urine collections, so we are collecting urine in from two different sources. So the main one is events and open air urinals. So we have contracts with companies in France and in Europe, like Nadège, from which we collect a huge amount of urine. So roughly, so the contract we have is almost 2 million liters, so not meters square, but 2 million liters of this source. Also open air urinals in Toulouse, so in the south of France again, in open air urinals, so just below 100,000 liters of urine. And the other kind of sources are urinals in buildings. So we have 3 different partnerships. So the main one is the Futuroscope, which is an entertainment park, in fact, like Disneyland Paris, where we have equipped the park with this urinals and a tank, a buried tank, where we collect urine directly, which is here in the blue picture. So sorry, it's not very easily visible, but it's we collect urine and stabilize it directly in the tank, and which is also quite easy to do. And we have also another interesting partnership with Vinci Autoroute, so which is one of the main concessionary in terms of gas stations, and so there are lots of issues coming from the urinals management in the gas stations. So we through this contract we transform the toilets with this waterless urinals and collect the urine at the end, to finally obtain an amount of roughly 3 million liters of urine collected in France. And finally, the production unit. Sorry, so here's the examples of all the urine collection here in this picture, and the final products in the bottom in IBC tank. So it's a quite, I would say, common fermentation units with a capability of again of 250,000 liters of productions of final product like Lactopi Start. We have 3 employees dedicated to the productions, and so 3 patents, and just have been submitted. So sorry for that. I need to update my slide. Yep. And then, and to conclude, also on the business model, it's I think it's interesting also to know that we, in fact, we don't want, again, like effect of VunaNexus, we don't want to sell products and I would say send products at across the world. We wanted to put in place and try to replicate these units, this units we have in Bordeaux at the territory scale to decrease of course the transport. So we wanted to in France, this is a typical example in France, we want to engage farming partners, so-called agricultural cooperative in France, in a JV model. So we ask them to co-invest with us in the units, like a joint venture a company. And at the end, this is a very interesting opportunity for them because it gives us financial opportunity and also help them to reinforce their local production distribution and decrease this price volatility of bio inputs. And in fact, Toopi wants to finance this by, I would say, selling the service and IP by an IP transfer technology. And the partners, so the cooperative, I would say, in this joint venture, we have the role to sell, to market and sell the product, and then to address their final members and customers. Thank you for your listening.
Thank you so much, Julien. Really appreciate how much you covered all the aspects of your business and give us so much food for thought. We're going to keep moving along. If you need an eye break, just take one yourself. I know we are all very engaged on these screens, so you make sure you take care of your eyes. Next, we're going to hear from Carsten Beneker, and Carsten will be presenting nitrification of urine and co-composting of nitrified urine in the zirkulierBAR project. So this is also involved with the VunaNexus group. Carsten is an ecological engineer with a process engineering background, currently working on the planning and implementation of 2 large urine recycling business cases in Germany, 500 liters per day each. He's passionate about the multidimensional objective of this approach, addressing nutrient recycling and water and soil conservation with new technology and concepts, while demanding regulatory and dietary change and while challenging industrial and socioeconomic frameworks. Are you ready to start, Carsten?
Yeah, I think so. Thank you so much for the introduction.
Yes, please go ahead and share your screen. We can hear you very well.
All right.
We'd love to have you share your screen. Great.
There's my screen.
All right, so there you go.
This was not the first slide. You see the slides now?
Yes, we can see them.
All right, great. Yeah, I'm glad to be contributing here. Hello to the recycling community. I'm really stoked we have this international exchange opportunity. Thank you for Richard Institute. I'm here to present to you it's a hard word, zirkulierBAR project. That's a German word. We are a nationally funded rural innovation project located just 1 hour from Berlin in the northeast of Germany. My name is Carsten Beneker, and I'm working for the Kreiswerke Barnim, which is basically like a circularity hub, a municipal one, operating there locally. And we are one of 11 consortial partners of this project. First, I will introduce to you the business and the project approach, and further on, I would like to be highlighting on the integration of stuff we call percurine into the VunaNexus nitrification process. and highlighting on the integration of urine into fecal matter composting. So the mission of our project zirkulierBAR is building an innovative and scalable recycling facility for the contents of dry toilets. For us, the end products have to be non-hazardous, nutrient-rich, and low emission recycling fertilizers for the application in agricultures. And we're really trying to come up with a blueprint for municipalities so they can plan and build a water saving and resource saving alternative to sewage systems. Our working packages are the technical one, then we have an agroeconomical one, where we have tests on 10 hectares, which is approximately 25 acres. We have a work package for the requirements for the market take-up and the acceptance on the demand side, and a working package for transfer activities into education, society, and policymakers. And we have a business partner, which is like the foundation of the project. Basically, they are operating since 5 years now, and they have additional goals to our mission, which is understanding the special requirements to produce a quality compost derived from human feces, while securing the decomposition of trace substances to achieve a safe product, and while understanding the design settings of nutrient-enriched quality composts. And a special question is how to optimize the water household of the compost. Can it be done with urine? Can it be done with nitrified urine? I will get back on that later on. So to give you an idea of the business of the company, which is called Initio, they have various urine dry diverting toilets with different user interfaces in their portfolio. You can see them here, but the main, like the cash cow, is really that kind of toilet that you see on the right hand side, which are used in festivals. They have more than 200 of these toilets in their fleet, and something is special about them. It is that they have a serial separation of the liquid content. You can see there on the lower picture that the bins actually have a drain. So the drain collects the liquid discharge and lifts it to the IBC. So we're talking about approximately 200 cubic meters per year of solid matter and approximately 300 cubic meters per year of liquid matter that we are planning to be treating next year. And this serial separation is somehow different from collecting urine as in a parallel separation. And this is a question that popped for us, like if this has been percolating through the solid matter, is it altered or not? And if it is altered, does it have effects on the treatment? And does it have effects on the quality of the compost and of the processing of the compost? So we have done, a bachelor student has done a first factorization that implies that the stored perchlorine, so we call this stuff perchlorated urine, perchlorine has a lower pH and lower phosphorus concentration compared to stored urine. And this might have implications on the VunaNexus process. Nadège has presented the process early on. It's working with an activated sludge process upstream, and this is like based on pH control. The pH range is very crucial on it. Obviously, if we have a resource that has a lower pH, it will have an effect on the control of the process, which we have to find out next year when we implement the urine treatment. If the resource has a lower P content, obviously the product will have a lower P content. This are just two implications that we foresee. And then on the second aspect of the project, I need to mention that we're not distilling the stuff just because it is a cost factor for us. Then the second thing, I need to introduce you to the composting approach of Pinizio, just sharing some pictures for that purpose. When the material arrives from the events, it gets lifted into this container, which is aerated, and it is in there for like 7 days and heats up to 70 degrees, just for the hygienization to kill pathogens. And after a week, it gets emptied, and then we form these kinds of heaps. This is like the state of the art of quality composting from Austria, which we are applying here. And this contains a lot of bulk material. Here you see clay minerals, which are added and which then need to be mixed. In the next step, here you see the mixer. For the first days, each batch needs to be mixed every day, actually, because it develops a lot of heat also. And then after 6 to 8 weeks, the compost is ready, it's stabilized, you can store it or you can apply it to the field. But you see, it's quite labor intense. And compost is really a multiple requirement field. You have a lot of external factors, environmental factors. The water content is crucial. It should be around 55%, and how to control this in different seasons. So sometimes it might be too juicy and sometimes it might be too dry. So water needs to be added. And we're thinking about adding urine there, but it comes with with more questions. Then urine has, as Julien said, a rather high water content or small nutrient content. So the compost needs to hold the water in order to be able to hold the nutrients as well. Then the carbon to nitrogen ratio is crucial for composting. It should be around 25, but fecal matter already has a CN ratio below 10. So you add a lot of nitrogen with the solids already. If you add urine, you have to have a close eye on the CN ratio. Well, then you have to have a look on the nitrification process of the compost itself, so you don't disturb it or overload it. You have, on the other hand, you have legislative phosphorus limits for the application, so you shouldn't add too many nutrients neither. And all this you need to balance out. By the way, we're thinking of using activated biochar to load it with urine also, and to add this combination later on maybe to the compost. Elena Bishak had an exciting talk on loading biochar yesterday. Thanks for that. Yeah, this is questions that we're coming up with basically. And here's one more picture of our vision Nadège has shared already. We want to automate this composting unit further with automated mixes, and also an irrigation unit where you can also add urine if it turns out this is the way we want to move forward. And all this is in the end of the planning phase. We got our permission now from the authorities, so we're gonna start building beginning next year. So I hope next year I can show you pictures of this automized treatment plant already. Yeah, so this is only to share our approach with you. We're very keen to get in contact with you. Please visit the website and sign up for the newsletter. We're very keen to get in touch. Thank you so much for listening and for the invitation.
Thank you, Carsten. Thank you, Carsten. Yes, we look forward to having you present again next year when you can show us the photos of what's been built in 2023. I think there's going to be a lot of things that are happening in 2023. It's our year, I think, coming up. Next, we're going to hear from Juliana Marks. She will be presenting about P for the Peonies, a demonstration of urine-derived fertilizer on peony plants. She is a senior undergraduate student studying environmental engineering at the University of Michigan. She is an undergraduate research assistant in the laboratory of Dr. Nancy Love in the biotechnology research group and is interested in nutrient recycling and resource recover. So are you ready, Juliana?
Yes, thank you. Can you hear me?
Yes, I can hear you, and you can go right ahead and share your screen.
All right. Can you see my screen now?
I can see your screen and we can hear you. Take it away.
All right, great. Thank you for that introduction. So today I'll be presenting on our project P for the Peonies, which is a demonstration of urine-derived fertilizer on peony plants. And I also would like to acknowledge the other students who have worked on this project whose names are listed on this slide. So the objectives of this project are threefold. First of all, it is a demonstration of non-food application of urine-derived fertilizer, or UDF, on 2 peony beds in the W.E. Upjohn Peony Garden. Secondly, it seeks to foster discussion about the safe and effective use of urine as fertilizer. And third, it seeks to build the foundation for a successful multi-year project. One of the problems that this project addresses is that nutrient inefficiency is a problem for most cities. Nitrogen, phosphorus, and potassium enter urban areas from sources such as food, and most of this leaves unrecovered. So as a result, these valuable resources go unused, and sometimes they end up as pollution in our waterways. To address this, we need to close the nutrient loop and move towards nutrient efficiency. Ann Arbor, Michigan, where the University of Michigan is located, is an example of a city where nutrient flows are inefficient. So this figure shows some of the work of another student in the lab with nutrient flows in and out of Ann Arbor. So this figure specifically shows nitrogen flows during the summer. And you can see that imported food is about 81% of the nitrogen coming in, and fertilizer makes up 14% of the nitrogen inflow. And a lot of this nitrogen ends up either lost as nitrogen gas emissions, or ends up in the landfills, or ends up in the Huron River, which is the main water body in Ann Arbor. On the topic of fertilizer, Matai Botanical Gardens and Nichols Arboretum, both of which are also part of the University of Michigan, are interested in more sustainable fertilizer options, as opposed to synthetically produced or mined commercial fertilizers. And they also have a number of ongoing research partnerships. So our mutual interests led to this collaboration that is the P for the Peonies project. And this project took place at the W.E. Upjohn Peony Garden, which is also on the University of Michigan campus and is maintained by Matai Botanical Gardens and Nichols Arboretum. This peony garden is home to about 800 peony plants, and at peak bloom, there's over 10,000 flowers. So it's a lot of peonies. So urine diversion offers a path towards nutrient efficiency, which we're looking for in this project, because human urine contains most of the nitrogen, phosphorus, and potassium in wastewater. And we can collect this urine and tailor it to a specific application as fertilizer through processing. So one of the main nutrients that we were looking at tailoring with this project was phosphorus. The P for the Peonies project consisted of 3 phases. So in the first phase, we processed the urine to create a UDF, which was then applied in the application phase to peony beds at the peony garden. And then in the third phase was results in outreach. So in the processing phase, the UDF was tailored to the peony garden soil. So through soil testing, we found that the soil had nitrogen and potassium deficiency, but that additional phosphorus was not needed. This is fairly common in the Midwestern United States, where phosphorus is used for agriculture and then will end up in waterways. And actually in the city of Ann Arbor, you're not allowed to use phosphorus fertilizer on lawns. So to tailor this urine for the soil at the peony garden, we removed the phosphorus by precipitating it as struvite, which is also known as magnesium ammonium phosphate. And the urine was also pasteurized and trace contaminants were removed using activated carbon. This schematic illustrates how phosphorus was removed from the urine in the laboratory using a reactor. So after the urine was pasteurized and went through activated carbon, it went into the reactor where magnesium chloride was added, and it was mixed mechanically for about 30 minutes. And during that time, a chemical reaction takes place where the phosphorus creates this struvite mineral compound, which is a solid, and then the phosphorus reduced liquid can then be flowed out through a strainer. The strainer catches the solid struvite, which can then be oven dried and saved for other applications where phosphorus is needed. And then we took the phosphorus reduced liquid fertilizer and applied it to the peony beds. So in the application phase, the UDF was applied to peony beds at the W.E. Upjohn Peony Garden. And 4 peony beds were involved in this project. So we applied the fertilizer, the UDF, to 2 beds, and then an additional 2 beds were not fertilized, but they were monitored as part of the project. So this picture shows a map of the peony beds. There was about 30 plants in each of the beds, and these are the 4 that were involved in the project. After fertilizer application, the 4 peony beds were monitored, and plant health data was compared between the fertilized and unfertilized beds. We took data on several different plant health indicators, including the number of buds, blooms, and bud blasts. Bud blasts are when the peony plant forms a bud, but that bud doesn't actually mature and bloom. And then we looked at leaf and stem discoloration, which could be a sign of disease or lack of key nutrients. And then finally, we looked at plant height and width. Though plant height and width can vary by the cultivar or peony plant variety, significantly smaller plant size could indicate a nutrient deficiency problem. So the data showed that there was no significant difference between fertilized and unfertilized beds. And this was not unexpected because we applied the fertilizer just before bloom time. And the goal is that this data will then serve as a baseline for a multi-year project where we may start to see differences between the fertilized and unfertilized peony beds in the future. In addition to monitoring plant health after fertilizer application, this project has a significant science communication and community engagement aspect. We placed informational signs regarding nutrient cycling throughout the peony beds that were involved in the project. And researchers also spent time engaging with garden visitors by providing more information about the research project, discussing individuals' roles in the nutrient cycle, listening to and learning about their own perspectives on UDF, and answering additional questions about the project. So these are some pictures of our signs throughout the peony garden, as well as us when we were out there talking to visitors. It turns out that the W.E. Upjohn Peony Garden provides an excellent platform for this outreach. The garden estimates that about 14,000 people visit the garden during the 2-week peak bloom period each year, which usually happens around late May, early June in Michigan. And we estimate that we talk to about 50 to 75 people in actual person-to-person discussion about UDF. Finally, the P for the Peonies project will continue in future years with similar soil testing, fertilization, data collection, and outreach procedures. And we also will be conducting further research on the impact of UDF on soil health. Lastly, I would like to acknowledge and thank our collaborators, and in particular, the Rich Earth Institute for their support of this project. And I would also like to thank NSF for funding for this project. Thank you for your time.
All right. Thank you, Juliana. Thank you so much. We look forward to more peonies in the future. We're going to keep moving along with my own co-founder of the Rich Earth Institute. Abe Noy-Hayes is going to give you a quick update on what we're doing at Brightwater Tools, where I'm the CEO and he's the Chief Technical Officer. I'm not going to introduce Abe. I have so much to say about him. So we all know who Abe is. Come sit down.
Great. Thank you, Kim. So this is going to be a brief presentation, not as long as the others. It is a project that is in progress, and so we wanted to orient you to what we are up to and what we're working toward. So is that screen sharing well?
Yes.
Okay. Wonderful. So yeah, as Kim said, in addition to my role at the Institute, I am also at Brightwater Tools, our spinoff, which is working on a building scale urine or all toilet water processing system. So this is the overall view of the system. We have waterless urinals or urine diverting toilets with acidification feeding into a wastewater tank, or potentially in the future, vacuum flush toilets with anaerobic digestion feeding into that wastewater tank. What we're working on particularly is this section here, freeze concentration and pasteurization, because this is our way of reducing the volume with lower energy use than distillation, but still very high retention, over 90% retention of nutrients, followed by pasteurization of the concentrate to remove pathogens. And not shown on here is charcoal for micropollutant removal, but that's part of the system. It's not shown on this figure. The outputs are the fertilizer, and then a reduced nutrient, reduced strength a effluent from the system that can go to gray water treatment for in-building reuse, along with other gray water sources. So this is what I'll be talking about for the rest of the presentation. I do want to mention that this part here, the anaerobic digestion of toilet waste, is one possible approach. There have been a lot of exciting discussions of different forms of aerobic or anaerobic digestion going on, including many at this conference. So I think there's a lot of great ideas on there that may end up in this system. What we're focusing on really, and our research and development has been putting the most effort into, are these two elements: the pasteurizer and the freeze concentrator. And the pasteurizer is something that we've done pasteurization of urine in our work at the Rich Earth Institute for many years. We've been building a pasteurizer to sell to other projects doing urine collection and in need of a sanitization system that is robust, simple, easy to monitor, and low in energy usage and in labor. So this is now a small unit that we've been working on and are currently selling. We are also working on the freeze concentrator. This is something we published it last year, or maybe the year before now. I think it was last year, about freeze concentration through a batch system. Very, very simple process compared to some of the more sophisticated crystallization systems. And this is something that we are still very much in the research and development phase. We will be offering those in the future, but we're still very much working on scaling that up. For these systems, we have 3 patents filed. 1 is approved, 1 pending, and 1 provisional. Our biggest news is that we recently got a $1 million grant from the National Science Foundation to do research and development of these 2 systems and the other tools, the acidification and the charcoal filtration. We will be continuing development of all those 4 tools, also developing a cloud-based monitoring and management system so that we can take most of the management work of these systems so that our clients don't have to be doing that management themselves. And then we'll be deploying next year a urine-only beta unit that will do the concentration and pasteurization, 2 more the following year. And then after that, working toward the fully packaged system that can manage both urine and toilet solids. And I just want to finish with a few details about the pasteurizer. This uses heat to sanitize the urine, and some of the advantages of this are that it's very well understood process, very well understood by regulators, and known to destroy pathogens. Also, because it's a purely thermal physical process, there is not any production of disinfection byproducts. This one that we have available sanitizes 60 gallons or 230 liters per day, which is around enough for 200 people to keep up with production of 200 people's worth of urine. So it could be a small community system. And it's easy to use and fully automated. And as I mentioned, if there's a Wi-Fi connection, then we're able to actually follow in real time what it's doing, review its logs, and assist in the maintenance and operation of these systems. So if this system is something that would be useful to anyone, that info for Kim is how to reach us. We would love to help you incorporate one of these into your project. So hopefully we'll have a lot more to say about actual implementation next year, but I just wanted to share this news about what we're currently working on and where we are at this moment. Thank you.
Thank you, Abe. Okay, so much fascinating information this morning, and we've had a lot of people asking questions. Let's see, let's get started. We have, let me check on the time. We have how many minutes? I don't have my sheet. How many minutes till we to
Got to
work?
11:40.
To 11:40. We have about 15 minutes. Okay, and then there's a break.
Mhm.
Okay, great. So let's start out here. There's a lot of different questions. We'll just go from the various people from the top to the bottom. So we'll start with Dr. Shon from Haley at Flush. She would like to know, is anyone looking at the student response in Australia in your project? Anyone looking at the student response to using the urine diversion systems? And are they living in the building with the UD, or do they have a choice to use the UD system or not a UD system? Can you answer that for us, Dr. Shon?
Yeah, thank you for the this question, Haley. So this is the basically for male toilet only, so waterless male urinal. So only male can have this urine diversion system. So we have not installed just a pedestal toilet system yet, but in the future, yeah, we are considering that. Also, student, in fact, they don't know yet. We just started our project, so now it's time to advertise and promote our project together with this opportunity for the response of the urine diversion. So still not many students understand what's going on for their urine, but this is good opportunity. We want to educate our students for a circular economy system, which is very well aligned with the current demand of our CO2 and then zero leakage discharge, also some of the wastewater treatment process, fertilizer crisis, we are in a situation to make a good circular economic concept to demonstrate with the student. And that's what we are operating. So that's our current situation. Thank you.
Thank you.
Okay. Let's see, let's go to, there's a lot of questions here. Let's ask to, this is to Nadège from Aurea. Can you explain more about the different, is the plan to sell the fertilizer locally or at the different sites? I guess you've already answered this in the chat. Why don't you go to the ones where we don't have an answer yet in the chat? Let's see. Okay. We would like to Julien from Toopi. Does Toopi have plans to expand the activities to the global south?
Yes, I'm sorry because I answered directly in the chat, but yes, of course, as I said, we are also going to in touch with some companies and academics and universities in South Africa and Kenya as well. So we already work with partners in the global south. Yes.
That's great. That's great. And could you talk a little bit more about the legal barriers and codes you had to work for before being able to install the urinals?
There's no legal barriers for the installation. In fact, I would say the main barriers were mainly for the market approval products, because of course it was quite difficult, especially in France, because they are quite strict to have such products in the market. We have this legal barrier mainly on the final product. Then for the collection was not really a problem in terms of legal aspects, I would say so. But it may be different in other countries.
Okay. Let's see, where's another question? For Juliana, from Jeffrey, for Juliana or anyone using activated carbon, maybe it's a better question for yesterday. But what happens to the activated carbon after filtration? Is it discarded into a landfill? How is it recycled? And what about the chemicals that get filtered? We have some response from Nancy. Does anyone else want to make a comment on the activated charcoal? Okay.
So
Okay,
based on our experience, yeah, just we are trying to utilize the powder activate carbon together with the membrane bioreactor system. So after we have saturation of the absorption physically, and then it becomes the more biological, the biosorption related to some of the removal of so they can remove their own way of the organic or some of the micropollutant. So we have not really creates the problem for this micropollutant issue after absorption of the powder active carbon. And after we have a fully saturated, if we cannot remove any more micropollutant in our MBR system, we try to replace little by little. It doesn't have to be whole activated carbon replaced at the same time. So we try to have like a 1% and 3% ratio of the every day. And then that's the more than enough without any serious replacement. So that's and definitely, I think that we have two choices after fully separation, possibly incineration or recycling, but the powder active carbon is not that much expensive. So we just send it to landfilling. That could be the most cost-effective way of the discharge of the disactivated carbon. That's what we are planning to justify.
Okay. Okay. I'm going to move to another question from Abe to Julien about the urine for the biostimulant production. Could you tell us a little more why you chose urine and if there was other possible media that you were considering?
So yeah, in fact, urine is very interesting because you have all the nutrients that are useful for fermentations, and also the ratio between all the components, all the nutrients are very interesting, and so it gives urine a direct value compared to the other medium we have on the market, which is very important. And also you have water in it, so you keep everything, and then you can have a very interesting medium to do fermentations. I know that I also have questions about sugar sources and carbon sources, because of course you need this kind of sources to do fermentations. So again, it will depend on the strains you have in spaces. For the lactic fermentations, for the first product, Lactopi Starts, we used a quite simple C6 sugar glucosic sources of sugar, but it could be different for other kind of strains, and that could also be of a kind of waste rich in carbon, but with some deficiency in nitrogens. And so in these cases, you could have interest to use urine to recalibrate, in fact, the ratio, the carbon nitrogen ratio.
Okay. Okay. Very interesting. Someone else has asked kind of a general question for all the different projects discussed this morning about microplastics. Is anybody looking at microplastics in urine? And I guess I'd like to say, and PFAS. Is any of these projects taking a look at that or have a concern?
Not the case for Toopi Organics, because it's not compulsory for the authorities. It was also the cases for the xenobiotics, even if we also show that we have the process can withdraw the majority of the compounds, but not microplastic. That's true.
Mm-hmm. Mm-hmm. Any other questions? I think we could go ahead and consider taking our break now. I just want to congratulate everyone that brought their information to this group today. You have a very attentive and rapt audience with just so many varieties of projects, the quality of the projects, the funding behind the projects, and the future of what people are putting together. So it's extremely inspiring. I'm so glad that we are able to be together in this way at this point in time. So let's take a break for 5 minutes, I think, and we'll be back at 10:40. So do what you need to do, rest your eyes, and we'll see you in 5 minutes. Thank you.